A Softek IT Consult.
All right. So let's continue with the lecture 2. Okay. So lecture 2 says we are going to be working with types and what and declaration. All right. Types are what? Come again.
This is my problem life.
Yeah. Okay. I see. We are just going to revamp and then what? We'll work on it. Types and what declaration. Types and declaration simply means what? Data types and what and declarations and initialization. Right. Okay. So in this week we will introduce to what? We'll be introduced to C++ data types. We are going to learn fundamental types such as booleans, character types, integer, floating point, void, and then sizes. Right. So we are going to learn what? Booleans, that is bool, true or false, 1 or 0, character, integer, floating point, void, sizes. They didn't add string. Right. Yes, sometimes string are not really added up to the C++ data types because I feel like it has been borrowed somewhere, but sometimes also added in some books. Let's see. So we are going to be introduced to declarations. We're going to learn structure of declarations, declaring multiple names, scope, initialization. All right. Okay. And then here. So let's get started. Let's get started from here. Data types. All right. Data types refers to the various forms data can be represented in a language. Okay. So if I say 1, if I say A, if I say true, like this, if I say AMA, this is what type of data. So what type of data is this? This is what? A number or integer. If I say A, this is a type of data. If I say this is a type of data, it is a what? It is a character. It is a single value. If I say true is a what type of data? That is a what? A boolean, either true or false. If I say AMA is a what? Combinations of multiple characters. So this one makes this one a boolean. So if I write maybe 1.2, write 1.2 here. Okay, this is what? A floating point. All right, float. It has a decimal. So this is a what? Integer. This is character. This is boolean. And then this is a string. Okay, so examples include integer, float, boolean. We've seen some of them right now. Are we following? Yeah. So the categories of data types, integral data types, that is integer, character, and boolean. All right. I wrote them. Integer is what can be negative or positive numbers. Character is just a single character. It can be letters, it can be numbers, it can be anything. As far as it is a single character, it is a character. And then we have boolean. Boolean can be written as what? 0 or 1 or true or false. Right. Okay. And then integral and floating point. Okay. Types are called arithmetic types. Integral and floating types points are called arithmetic. As I said, 1, 2, 3, and then we have what? 1.0, 1.1. These are what? Arithmetic data types because they deal with numbers. And then we have enumeration and classes. Data types are called user-defined data types. What do I mean? Remember that what? In the beginning, I mentioned something like what? Predefined data types. You remember? Yes. And what did I say? What did I say that was?
Like they're already part of the
Exactly. So like these ones, they came with the program, but these ones are what? User defined, which means the user is the one creating it. Are we together? So this one becomes user defined. So when we talk about one, we call what? We call classes. We call one classes. That is in the object programming. Then we call one also as structure. Structure is a data type. Okay, that is created by the user. So the structure can create a data type from using this particular predefined data types. And then you can also use the same predefined data types to create a new data type in a class. So the ones that are created by the users are called user defined data type. Example, classes. Example, structures. Okay, the last one says fundamental data types are also like pointers and references are called built-in types. Yes. So pointers and references, they're already in the programming language. When I talk about a pointer it refers to to like an address. Okay, an address to to a variable. Okay, let's assume I put a house here, right? This is the house, and this is a signboard. Okay, this is a signboard. Okay, so whilst I was coming from this particular lane, I'm going to this house, but I don't know the house. When I got to this particular signboard, it showed that oh, you are 5 minutes away from house 59. So you know that this particular signboard has given me the address of this particular house. Are we together? So I've been able to use the address, the signboard to identify that the house is here. It is the same way that okay, pointers act like. Okay, so assuming maybe I say A is equal to 10. In the computer memory, A can be equal to maybe 0x B C 910. Okay, yeah, so this is an actual variable. The actual variable has an address of this, but okay, I can create a pointer. I'll say that star. Pointers are created using star. I'll say star B. Okay, B should be should be equal to A, which means that I'm giving the address of of A. Okay, I'll put ampersand here. I'll put ampersand, and which means I'm giving the address of A to B. Are we together? So meaning anytime I want to find A or where like this particular house. So let's assume this house is A. This signboard is B. Right. So I use the address to find the actual house. So a pointer acts as as an intermediary, or it acts as a point of contact to the actual element. Are you getting what I'm trying to explain? Yes. Okay, so assuming maybe like this, let me write it in code for you to really see what I'm doing. Okay, look at this. What I will do here, I'm going to write an integer. See something, integer number, is equal to 10. See, right. And then I'm going to write a pointer like this. I'll put maybe I'll say it is called PTR is equal to maybe number. Let me say it is equal to number. Let me see, maybe yes, I think should be this way rather. Let me see. Okay, I think this one, the address. So this one, wait. Okay, look at this. So this is this is the actual number is 10. But see what I'm going to show you. Pay attention to something here. And I say C out. Okay, I want to print number. Look at something. I'll print number. Here. Okay, so you know this is going to print 10, right? And then here, I'm going to print address of 10. Look at this. This is the address of 10. If you want to print address of a number in the memory, we say what? We use the end. Right? And then I'm going to also print this particular pointer. Let's see what happens. See out PTR. I hope you are following the code.
Yeah, I'm following.
Yes. So let me click on it. Okay, so what are you saying? What are you saying?
10.
Yes, and then what again? Exactly. But you see, the last two, they are the same, right?
Yeah.
But the question is, and that is the question. Why are they like that? Yes, that is going to be the question. Why are they like this? So I'm going to explain. Okay, yes. So pay attention. So here, as I said, this is what I assign. So assuming I have a container here, right? This particular container is called A, and A has 10 inside. So this is maybe the computer memory is here, right? Memory. So maybe in the memory has been divided into so many. So maybe this portion, okay, is keeping this portion as A has come to take this particular portion. E has taken this particular portion, right? So this portion has 10 inside. Are we following? Are we following?
Yeah.
So in the memory, okay, this particular side has the address called 0xC76. As you can see from here, this address. So anytime that's what you call for 10, or anytime you call for A, okay, it is calling it from this particular address. It is like having the classrooms in the school, okay, C1, C5, C4, okay. So that particular C1 written on top of the room, okay, is the what? Is the address. But the classroom inside is the what? Is the 10. Are we paying attention? Are we paying attention in the class? Yes. So anytime I want to visit the room, I have to use the address. So in the memory, okay, this particular memory portion, memory is like this. And memory has what? Divisions, portions, okay? So memory has what? Addresses. Address 1, address 2, address 3, address 4, address 5, address 6, address 7, and then it goes on like that. So when I placed what? I placed A somewhere here. So the address of 4, maybe the address here was maybe 0xC764FF. You understand? So that address has been given to A. Are we clear now? You are tired, eh? You are feeling sleepy. So we should pause here and then come and continue later tomorrow. Yes, because I want you to just pay attention to what we are doing. Okay, so I think you will end the class here. So I'll not save this one, but I'll leave the first one because the first one we completed. So I think, and then it is also good for you to understand this particular concept. It is very important. This particular concept, okay, is very, most of the times lecturers know students don't like this particular topic, pointers, references in programming. So they can load them in session A. So that's what they'll get them wrong. Okay, so we will end it here probably tomorrow. Tomorrow we'll start early. Today we didn't start early, and then we'll see that maybe we can do more. Okay, but I hope at least you've been able to learn something from the beginning to this particular point. Yes, absolutely. That's great. Okay, then we'll call it off, and then we'll call it a day. If God willing, if God permits, we'll meet tomorrow. Okay, until we meet again. The name is Kwame A Class, and I'm out. Watch out, fish along. Bye bye.
For more information and also to reach us, please contact the numbers on the screen. You can also reach us through our social media handles displayed on the screen. Please do like, follow, and subscribe to our social media handles. A Softek IT Consult. Innovative solutions with the difference.